Well, thank you. Yes, girls. Now this is page 11. We have another 11 pages after that. Quickly, a simplified diagram of the electron gun in the Australian synchrotron is shown in the figure. An electron leaving the filament at A is accelerated through a potential difference of 90 kilovolts to B. So from A to B, negatively charged, and positively charged. All right. So electron is accelerating through a potential difference of 90 kilovolts. The electron experiences a force of 7.2 times 10 to the power minus 19 newtons. Which one of the following is closest to the magnitude of the electric field between A and B? Now, normally they ask you the speed, but this time they give you the force and ask you to find the electric field. Now, careful. If the force is known, how can we find the electric field? We know this. Electric field will be simply F divided by Q, and F is 7.2 times 10 to the power minus 14 divided by charge of an electron, which is 1.6 times 10 to the power minus 19, and that gives you an electric field of 7.2 divided by 1.6 is 4.5. 4.5 times 10 to the power 5. Yeah. Now, the trick to this question is, because in your formula sheet it writes E equals V over D, right?
Yeah.
And V is provided 90 kilovolts. So you tend to feel obliged to use this formula because electric field between charged plates, it's V over D, right? So it's 90 kilovolt over the distance between the plates, which is not provided. What you gonna do? You're stuck, right? Yeah. But it's not gonna help. But this one, so this is not useful for this setup. But this is, because force is provided, charge you already know. So you need to have the grasp of all the formulas so that you can manipulate them to the question. All right, moving on. Next one. Yes?
Is there a general way of answering? Is there a general answer, like B, E, F, or something like that? Like methods?
Like going from the choices?
Yeah, is there a general pattern?
No, there's no pattern. There's no pattern, but they don't use that. There's sometimes a trap. So what I can tell you is, if you think A is the right answer, think again. That's the only thing I can tell you about the choices, because sometimes they put the very attractive but wrong answer as the first choice, and the moment you see it, you feel or you're kind of encouraged to circle that. So if you think A is the right answer, think twice. Right? Moving on. A beam of electrons is moving to the right at a speed of 2.5 times 10 to the power 8 meters per second. The beam enters a magnetic field of 0.27 Tesla that is directed into the page as shown. After entering the magnetic field, each electron experiences an acceleration closest to. Again, a tricky question. Normally they ask you about the force, but this time they ask you about the acceleration. How am I going to find the acceleration? Look, knowing the velocity and the magnetic field, we can find the force, right? Which will be Q times V times B. I know everything, charge, V and B. And that's going to be the net force. How am I going to charge the acceleration?
You do F equals MA.
Yep, that is M times A. So I can then find A, that equals Q times V times B divided by M. It's always, girls, advised to first solve the equation symbolically, having a nice equation, alright? for the question, which is A, the acceleration, and then substitute. Why don't you substitute and get the answer if your answer is one of the choices? If the answer is one of the choices. Look, this doesn't make sense. I can tell you that much. Minus 11. It can't even move 1 meter in 1 second.
Is it B?
What kind of an accelerator is this?
Is it B?
I have no idea.
Oh, okay. Well, yeah, I got B.
It is, yeah, B.
B, you all happy with that?
Yeah.
Right? Look, in questions like that, I'll tell you a trick. In questions like that, if the choices all have different numbers, all right? What I normally do is, I just do this 1.6 times 2.5 times 0.27 divided the mass, 9.1. Do this, what do you get? 1.18. And I say it should be 1.2. See, I don't even care about the powers anyway. I mean, it's power 10 to the power minus 19 or 90, doesn't matter, because the bottom line is you're going to have these numbers multiplied and divided. So you get 1.18, so this should be the answer. Even though if it is not 1.18, or even though you get 118, all right, you can say it should be that one. Right? Even though you get 118, it should be 1.2. Making sense? So it might save you some time rather than doing all these 10 to the powers. If it is a multiple choice question. Question: the radius of the electron's circular path after entering the magnetic field is closest to, then you look at your formula sheet to find the radius of the curvature, which will be Q times V divided by
No, so it's
It's
M
n times V, yes, n times, yeah. So n times V divided by Q times V. Now, this is a good question, because M and Q is provided, V and B is provided, so you can easily find R. And again, you can use my method. Why don't you use my method, if it makes sense? Because according to my method, it's going to be 9.1 times 2.5 divided by Q 1.6 times magnetic field 0.27. What do you get after that when you do this?
You get
52. Point 7. Alright? Now, it's D. Alright? Making sense?
Yes.
As you see, I haven't dealt.
Huh? Yes, so isn't that risky? Because I mean, like that almost.
Oh yeah, if there is 1.3 times 10 to the power minus 3, 1.3 times 10 to the power minus 2, 1.3 times 10 to the power minus 1, obviously you can't. But since they are different, you can. Alright? These are all little tricks that saves you time. Alright? Or you can just do it like that in 30 seconds, and then if your time allows, you come back and do the wrong thing. Make sense?
Yes.
Moving on. See, accelerator and turner, let's say. Accelerators, electric field, turner, magnetic field. So the magnetic field is turning it, electric field